We talked about what a rational expression is. We talked about multiplying, dividing, natural next step, adding and subtracting. The rules for adding and subtracting is the same as the rules for fractions, where if I'm adding or subtracting, I need a common denominator. I need the denominator of this and the denominator of this to be the same. Here they are. So just like with regular numbers, regular fractions, when they add, my denominator sticks around, and I just add the numerators. I add 4x minus 5 plus x plus 4, and that makes 4x plus x makes 5x, minus 5 plus 4 makes minus 1 over 3x plus 1. When I finish, I should take a second, see is there a common factor that cancels. There's nothing here to factor, so nothing cancels, but I should take a second to check if my rational expression simplifies more. This one, there's no factoring, so nothing's going to cancel. This problem, again, I already have a common denominator. That's nice. So I know my answer is just going to be something with that common denominator. And just like with fractions, I subtract from the first one, I subtract the second one. I do 2x plus 7 minus x plus 10. I do 2x plus 7 minus x plus 10. Here you should look at it and be like, oh, okay, I see how this gets tricky. Because it's possible to forget to put these parentheses around the whole thing, and then you'll forget to distribute the minus. Right? It has to be 2x plus 7 minus x and minus 10. The minus has to go to both things. If you don't do the parentheses, you might forget that. This all cleaned up makes x minus 3 over x squared plus 2x minus 15. Before I move on, I take a second to pause and check, does this simplify even more? I don't know unless I simplify it. I have x minus 3 over x plus 5, x minus 3. You know what? This does simplify. I can cross off an x minus 3 on top and bottom, and I'm left with 1 over x plus 5. Now, what happens if they don't have a common denominator? With fractions, I know what happens. With fractions, I have to give them a common denominator. I have 2 over 5 plus 1 over 3. To give them a common denominator, I'm going to make sure that there's a 3 in this bottom, and I do that by multiplying top and bottom by 3. And I make sure there's a 5 in the second denominator, and I do that by multiplying by 5 to the top and bottom. So I have 6 over 15 plus 5 over 15, which makes 11 over 15. In the second one here, I have 1 over 2 minus 3 over 10, and we could probably do this without this step, but I have a purpose in this. 10 I'm going to factor. I'm going to write it as 2 times 5. And I do that because now I can see what I need to do to the first denominator to make it look like the second. I need to do times 5. I'm doing this so that we kind of redevelop our intuition on how it works with fractions. That way when it comes to rational expressions, we can kind of continue it. 5 tenths minus 3 tenths makes 2 tenths. Before I move on, I pause to see if it simplifies. Yep, simplifies to 1/5. This one, I have 5 over 12 plus 4 over 15. To give them a common denominator, well, there needs to be a 5, and if there's a 5 in the second one, there needs to be a 5 in the first one. So I'll multiply by 5 to top and bottom. I have these 2's in the first denominator, so I better put a pair of 2's in the second denominator. Now both denominators match. Both denominators are 3 times 2 times 2 times 5. So I have 25 over 60 plus 16 over 60 makes 41 over 60. This page, we could have done this without this video. I assume we all know how to add and subtract fractions, but this helps us be ready to do a problem like this. Here I have 2 over x plus x over 3. Sometimes I have to factor the denominator. Here there's nothing to factor, but I can look and I say, you know what? This second fraction has this 3, but the first one doesn't, so I better put a 3 in there to help make them match. And always times, I always multiply. The second fraction has an x in the denominator, so I better put an x here in the second denominator to make them match. Now both denominators are 3x. The first fraction, the numerator is 6. The second one, it's x squared. So when I add them, I get 6 plus x squared over 3x. If you're someone who likes things in standard form, it's x squared plus 6 over 3x. I look what's missing in each denominator, and I put it. Maybe more practice will help. Here I have 1 over 2 times x minus 3 over, you notice I'm making these fraction bars big because I'm trying to leave room, 5 times x times x. I wrote it as factored out as I can because now I see, oh, there's a 5 here, so I better make sure that there's a 5 here to match. There's a 2 here, so I better make sure that there's a 2 here to match. The second denominator has an x that matches up with this x, but there's still a missing x. So I better make an x in the first fraction. Now the denominators match. Both fractions on bottom are 10x squared. They both have a 5 times an x times a 2 times an x, just in different orders. My first fraction has a 5x on top. My second one has 6 on top. So when I subtract, I get 5x minus 6 over 10x squared. I pause, say, oh, does this simplify more? Can I factor? Nothing factors. It's as simplified as can be. Another. I have 5 over 2 times x. I make the denominator as factored as I can. That way I can see all the little factors that need to go in each thing. There's an x in both of them, so that's fine. But the first fraction is missing that 3. And the second one is missing a 2. So now they match. Now both of them have a 6x on bottom. 3 times x times 2, that makes 6x. First fraction is 15 on top. The second one is 2. 15 plus 2, that makes 17 over 6x. I just did 15 plus 2 over 6x. 17 over 6x. Does it simplify? Does it factor and things cancel? Nope, nothing factors, nothing simplifies. This one. Now we get into a little bit more complicated, just a step up in difficulty. Here I have 7 over x plus 2, and I'm going to put that in parentheses because if I multiply something in, I need to make sure I multiply it to the whole thing. X plus 2 kind of sticks together. Plus 3 over 2x plus 4, well that's 2 times x plus 2. Because I factor, now I see the only thing missing is a times 2 in the first one. I have 14 over x plus 2 times 2 plus 3 over x plus 2 times 2. The order I multiply things doesn't matter. That's called multiplication commuting. So I'm left with 14 plus 3 over x plus 2 times 2. 17 over 2x plus 4. Does it simplify if I factor? Does anything cancel? No. Here I have a 7 over 2x plus 3 minus 3 over x plus 5. I need the denominators to match. Everything that's in this denominator needs to go here. Everything that's in this denominator needs to go here. So I'm going to put a x plus 5 in the top and bottom of my first fraction. That way there's an x plus 5 in both denominators. And I'll put a 2x plus 3 in the top and bottom of my second fraction. That way there's a 2x plus 3 in the denominator of both. Now both denominators are the same. I have 2x plus 3, x plus 5, 2x plus 3, x plus 5. In my first numerator, I have 7 times x plus 5, 7x plus 35. In my second numerator, I have 3 times 2x plus 3, 6x plus 9. The only thing is I need to make sure when I subtract that I subtract the whole first numerator by the whole second numerator. So I do all of 7x plus 35 minus all of 6x plus 9. That leaves me with, I'm just going to distribute the minus 6x minus 9. Notice how I keep the denominators factored. I don't FOIL it out. If I FOIL it out, then later I might have to factor it again. So for now, I'm just going to keep it factored. My numerator is 7x minus 6x makes just x. 35 minus 9 is plus 26. If my numerator factored, I would factor that to see if anything cancels at the bottom. Nothing does. Moving on. This one, I have x plus 3 over something. That something is x minus 2 x plus 1. This factors to this. And my second fraction is x over x minus 2. Now I see I have an x minus 2 in both denominators, so that already matches. To make it fully match, I need to put this x plus 1 into my second fraction. Now both denominators match perfectly. My first is x minus 2 times x plus 1 with an x plus 3 on top. My second fraction is x minus 2 times x plus 1 with an x squared plus x on top. When I add it together, my common denominator sticks around, and I'm left with x plus 3 plus x squared plus x. In other words, I have x squared plus 2x plus 3 over x minus 2, x plus 1. I check, I see is something going to simplify. If something simplifies, it would come from factoring. So does my numerator factor? Multiplies to 3, adds to 2. No, nothing does that. So nothing to simplify. Last one. I promise this is the last one. Okay, I have x over x squared minus 4. X squared minus 4, that's like x minus 2, x plus 2, because it's difference of squares. So I have x over x minus 2, x plus 2, minus 10x over x minus 2. It looks like I already have x minus 2 in both denominators. I just need to put a x plus 2 into my second fraction. So I have x over x minus 2, x plus 2, minus, if I distribute the numerator, 10x times x makes 10x squared, 10x times 2 makes plus 20x. My denominator is x minus 2, x plus 2. I am careful to make sure I do the whole first numerator minus all of the second. In other words, I make sure to use parentheses so that I know to distribute the minus. My denominator stays the same. I have x minus 2, x plus 2, x minus 10x squared minus 20x. I see some like terms. X minus 20x makes negative 19x, but I'm not going to write that yet because I should really do this in standard form. I have negative 10x squared minus 19x all over x minus 2, x plus 2. I should check before I say I'm done. I should check to make sure nothing simplifies. If I factor the top, I have negative x times 10x minus 19 over x minus 2, x plus 2. Nothing simplifies. I'm good.